Thank you, Jason. Hello, everybody. So today I will move on and kind of coordinate with Hernan because we are working on very similar things. I wanted to present a broad overview of OU's strengths into addressing very key challenges of the water cycle. Traditionally, hydrology in a broader sense has been broken down into subdisciplines, and we have been focusing on separate components of the water cycle. But recently, we see an emergence of a more comprehensive understanding of those components. And we are in a position to bridge gaps between water science and engineering. It is linked to the fact that we have more and more observations. And here is an example of the past, current, and future missions from NASA, which aims at sampling the hydrologic column. So we see also other agencies moving toward a combination of missions that enable to monitor the water cycle at a global scale. And at OU, we have relevant strengths in that regard because we have expertise working with satellite observations, like the GOES-R mission from NOAA, the Global Precipitation Measurement from NASA, focusing on weather, climate, and water resources. At OU, we also develop ground platforms like radar systems with the Advanced Radar Research Center. We work with the national radar networks with the MRMS. With the MRMS project led by NOAA and SSL. Hernan mentioned drones. We have also expertise in autonomous sensing, and we use also expertise from citizen scientists, which enable to compare all of those observations. And we make use of those observations for hydrological modeling. I'm not covering that extensively. Hernan provided nice examples. And another thing that I want to highlight is that we have on the Norman campus a unique ability to build and deploy systems from research, which can be a shaky road, toward operations, where we can really impact people. So here is some examples. We have a unique expertise in weather radar systems, and NASA came to us because they wanted to validate their observation of the water cycle at a global scale. So we had a successful project spanning several years now, where we intercompare water as seen from space and water seen from ground to improve our precipitation understanding at several scales, and also flood monitoring and forecasting. We were able also to build a system that benefits from the NextRad-based radar network and force a fine-scale hydrologic modeling at a continental scale to predict flash floods. So I will talk about a specific project that I think might interest some of you. We are interested into risk monitoring, especially here, flash flood risk. So we have observations over the corners, over the United States, observations that tells us, okay, when you observe some discharge value, you can relate that to a minor, moderate, or major flood. However, those observations are not available everywhere. And if you see over Oklahoma, we have only a handful of them. But by connecting hydrologic characteristics of basins and hydroclimatology, we are able to predict that information over the whole corners. And then we can, in real time, predict related discharge, either observed or modeled. Example, with this high-resolution hydrologic modeling I mentioned shortly ago, we can relate those discharge to probability of experiencing minor, moderate, or major floods. So here's an example with the Arkansas campground disaster, where this is a prediction from these operational hydrologic models that we transitioned to operation recently. And here are the location of the campground and the way we interpret this field into probabilities of experiencing different categories of floods. You can see, well, that we were able to identify that only one stream on these regions was related to major floods, and that was the one that impacted the campground. So here's an example. I am open to discussing with you and to questions. Thank you.